Class 9th Science Audiobook Chapter 3 Atoms and Molecules. Ancient Indian and Greek philosophers have always wondered over the unknown and unseen form of matter. The idea of divisibility of matter was considered long back in India. Around 500 BC, an Indian philosopher, Maharshi Kanad, postulates that if we go on dividing matter, padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles Parmanu. Another Indian philosopher, Pakudha Katyayam, elaborated this doctrine and said that these particles normally exist in combined form, which gives us various forms of matter. Around the same era, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these indivisible particles atoms, meaning indivisible. All this was based on philosophical consideration and not much experimental work to validate these ideas could be done till the 18th century. By the end of 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why elements combine and what happens when they combine. Anthony L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. 3.1 Laws of Chemical Combination. The following two laws of chemical combination were established after much experimentation by Lavoisier and Joseph L. Proust. 3.1.1 Law of Conservation of Mass. Is there a change in mass when a chemical reaction takes place? Activity 3.1. Take one of the following sets X and Y of chemicals. X first copper sulfate, Y sodium carbonate. Second barium chloride, Y sodium sulfate. X third lead nitrate, sodium chloride. Prepare separately a 5% solution of any one pair of substances listed under X and Y, each in 10 ml in water. Take a little amount of solution of Y in a conical flask and some solution of X in an ignition tube. Hang the ignition tube in the flask carefully. See that the solutions do not get mixed. Put a cork on the flask. Weigh the flask with its content carefully. Now tilt and swivel the flask so that the solution X and Y get mixed. Weigh again. What happens in the reaction flask? Do you think that a chemical reaction has taken place? Why should we put a cork on the mouth of flask? Does the mass of flask and its contents change? Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. 3.1.2 Law of Constant Proportions. Lavoisier, along with other scientists, noted that many compounds were composed of two or more elements, and each such compounds had the same elements in the same proportion, irrespective of where the compound came from or who prepared it. In a compound such as water, the ratio of mass of hydrogen to the mass of oxygen is always 1 is to 8, whatever the source of water. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14 is to 3 by mass, whatever the method or the source from which it is obtained. This led to the law of constant proportions, which is also known as the law of definite proportions. This law was stated by Proust as in a chemical substance, the elements are always present in definite proportions by mass. The next problem faced by scientists was to give appropriate explanation of these laws. British chemist John Dalton provided the basic theory about the nature of matter. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. He took the name atoms as given by the Greeks and said that the smallest particles of matter are atoms. His theory was based on the laws of chemical combination. Dalton's atomic theory provided an explanation for the law of conservation of mass and law of definite proportion. According to the Dalton's atomic theory, all matter, whether an element and compound or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. All matter is made of very teeny particles called atoms, which participate in chemical reactions. Second, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Third, atoms of a given element are identical in mass and chemical properties. Fourth, atoms of different elements have different masses and chemical properties. Fifth, atoms combine in the ratio of a small whole number to form compounds. Sixth, the relative number and kinds of atoms are constant in a given compound. You will study in next chapter that all atoms are made of still smaller particles. John Dalton was born in a poor weaver's family in 1766 in England. He began his career as a teacher at the age of 12. 7 years later, he became a school principal. In 1793, Dalton left for Manchester to teach mathematics, physics, and chemistry in a college. He spent most of his life there teaching and researching. In 1808, he presented his atomic theory, which was a turning point in the study of matter. What is an atom? 3.2. What is an atom? Have you ever observed a mason building walls? From these walls, a room and then a collection of rooms to form a building. What is the building block of the huge building? What about the building block of an anthill? It is a small grain of sand. Similarly, the building blocks of all matter are atoms. How big are atoms? Atoms are very small. They are smaller than anything that we can imagine or compare with. More than millions of atoms, when stacked, would make a layer barely as thick as this sheet of paper. Atomic radius is measured in nanometers. 1 by 10 to the power 9 meter equal 1 nanometer. 1 meter equal 10 to the power 9 nanometer. Relative sizes. Radii in meter. Examples: 10 to the power minus 10 atom of hydrogen, 10 to the power minus 9 molecule of water, 10 to the power minus 8 molecule of hemoglobin, 10 to the power minus 4 grain of sand, 10 to the power minus 3 and 10 to the power minus 1 apple. We might think that if atoms are so insignificant in size, why should we care about them? This is because our entire world is made of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Through modern techniques, we can now produce magnified images of surface of elements showing atoms. 3.2.1 What are the modern day symbols of atoms of different elements? Dalton, Dalton was the first scientist to use the symbols of elements in a very specific sense. When he used a symbol for an element, he also meant a definite quantity of that element, that is one atom of that element. Berzelius suggested that the symbol of letters a symbol of elements be made from one or two letters of the name of element. In the beginning, the names of elements were derived from the name of the place where they were found for the first time. For example, the name copper was taken from Cyprus. Some names were taken from specific colors. For example, gold was taken from the English word meaning yellow. Nowadays, IUPAC, International Union of Pure and Applied Chemistry, is an international scientific organization which approves the names of elements, symbols, and units. Many of symbols are the first one or two letters of the element's name in English. The first letter of a symbol is always written as a capital letter, uppercase, and the second letter as a small letters lowercase. For example, hydrogen H, aluminum Al, and not A capital L, cobalt CO, and not a C capital O capital. Symbols of some elements are formed from the first letter of the name and a letter appearing later in name. Example are first chlorine, Cl, zinc, Zn, etc. Other symbols have been taken from the names of elements in Latin, German, or Greek. For example, the symbol of iron is Fe from its Latin name ferrum, sodium is Na from natrium, potassium is K from kalium. Therefore, each element has a name and a unique chemical symbol. Passage of time and repeated uses, you will automatically be able to reproduce the symbols. Thank you for this time. Have a nice day.